Welcome back. In the first video, we introduced altitudes of triangles and saw that they will always intersect, and they intersect at a point called the orthocenter. Okay? I didn't really talk about how to remember, maybe a good way to remember the orthocenter. So your altitude is the one that comes when you have the base. If you turn your triangle around so it's at the bottom, your altitude will always be the side that comes straight down at a 90-degree angle. Okay, so what I like to remember is if you've ever been to an orthodontist, or you know someone who, if you've had braces, or you know someone who's had braces and has gone to an orthodontist, okay, then you know that their goal is to make your teeth come straight down from your gums, right? Not to be crooked coming out of your gums, not to come out at a strange angle. So they want them to come straight down at a 90-degree angles out of your gums. Well, it's an orthodontist, and they straighten your teeth, right? Your orthocenter is the one that comes straight down at that 90-degree angles, not necessarily crooked, right? Because we're going to look at some lines in the next couple days that come out of this angle maybe a little bit off, okay, a little bit crooked. Okay, so our orthocenter straight down at the 90-degree angles, just like our orthodontist straightens our teeth straight down from a 90-degree angle, okay? All right, so let's look at some examples of things we might see. My first question here is, if WY is an altitude, what do we know about this figure? Okay, so if WY is an altitude, let me bold that in so we can see which segment we're talking about. So that's this one here. If it's an altitude, when I look at this picture is very deceiving because it looks like lots of things are the same. It looks like it's isosceles. It looks like this is a midpoint. It looks like these angles could be the same. It looks like these angles could be the same. But since nothing tells me this picture is to scale, I can't just assume it's to scale. So what I need to do is just go off the word altitude and what I know about the definition of an altitude. And all we know is it's perpendicular to the side across from the vertex it leaves. So all I know about this line here is that it's perpendicular to this opposite side. Okay, so I know that YW, segment YW, is perpendicular to segment XZ. Remember, this upside down T means perpendicular. Okay, the only other thing I could say about this is that this angle is 90 degrees and this angle is 90 degrees. Those are the only other things I could say. So XWY, that angle, is 90 degrees, and this angle on this side is 90 degrees, ZWY is also 90 degrees. So even though it looks like there's other things that we could say, it looks like these two are congruent, it looks like these two are congruent, we can't ever say, oh, well, it looks like it. We can just see it, right? We have to be able to use the information they've given us to be able to make assumptions about the picture, because we can't ever assume a picture is to scale. Okay? All right, the next thing we're going to do is we're going to draw, well, we don't have to draw the triangles, they're already drawn for me. We're going to draw the three altitudes, and then we're going to identify the coordinates of the orthocenter given the vertices of the triangle. Okay? All right, so when I look at this first one, I have D is at 3, 4, so this is point D. E is at -2, -1, -2, -1, so this is E, and F is at 4, -1, so this is F. Okay? All right, so what we need to do to draw in our altitudes, because it wants us to draw in all three altitudes, is we're going to have to remember that they're perpendicular, so they're going to have opposite reciprocal slopes. So let's say we're going to go alphabetical. Let's say we start at D. Okay? If I start at this point, then I'm going to look at the side across from it. I'm going to look at EF. And if I look at the slope of EF, I can see it's horizontal, which means it's a slope of 0. So my perpendicular slope to that is going to be not horizontal, but vertical, which we also say is undefined. So from that point D, if I go vertical, straight down to the other side, that is going to be my altitude. it's going to hit the opposite side at a 90-degree angle. Okay, let's do the next one. When I look at the next one, we'll go with E, alphabetical. So if I'm looking at E, then the side across from E is DF. So we're going to look at the slope of DF, which is I have to go down 1, 2, 3, 4, 5, and over 1. So down 5 over 1. Okay? So my perpendicular slope is going to be the opposite. So this one was down 5 over 1. So the next one's going to be up. It's going to be positive. And instead of 5 over 1, it's going to be 1 over 5. Okay? So from point E, I'm going to use this perpendicular slope. I'm going to go up 1 over 1, 2, 3, 4, 5. Up 1 over 1, 2. I fall off my line. So I can only put those 2 lines on there. I'm going to go ahead and use this to make myself a nice straight line so that I can find that intersection to draw in my altitude, 90-degree angle. Okay, one more for the last one. Point F. When I leave there, I'm going to be going across to side DE. So I'm going to look at the slope of DE. My slope of DE, I have to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. So that's just a slope of 1. The perpendicular slope of 1 is, if this is positive, then this one's negative. And 1, when you flip 1 over 1 flips over to be just 1. So my slope is going to be a negative 1. Now when I leave F, a slope of negative 1 would be down 1 over 1, down 1 over 1, but I want to go towards the opposite side. So instead I'm going to go up 1, back 1, up 1, back 1, up 1, back 1, till I hit the opposite side. Okay, draw in my altitude. There we go. Okay, so I've drawn in my 3 altitudes, which it asked me to do, and then it says to find the coordinates of the orthocenter. So the coordinates of my orthocenter are right here, which I really knew after I did the first 2, because I could see where the blue and the brown intersected, right? So I knew right away where my orthocenter was before I even did the green one there. My orthocenter is the point 3, 0, right? It's right there at 3, 0. Okay, let's look at the next one. All right, triangle RAM. Go Rams. -1, 6, -1, 6. This is R. 7, -6. 7, -6 is A. And -7, 2 is M. Okay, so let's figure out where our altitudes are. Starting with, we'll go in the order of RAM, right? So I'll start at R. When I go across the side I'm going to be looking at is AM or MA. So I'm going to look at the slope of AM or MA. So I can see it's going down. I have to go down a whole lot. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Down 8. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whew. Down 8 over 14. Those are both even, so down 4 over 7. My perpendicular slope is going to be opposite, so if this one's negative, this one's positive, and then the reciprocal, 7 over 4. So from R, I would go up 7 over 4, but that's going to take me the wrong direction. So instead, I'm going to go down 7 and back 4. So my altitude is going to be, now I know my point is outside the triangle, but remember your altitude is the distance from the point to the opposite side at a 90-degree angle. So I don't extend past the opposite side. Okay? If this turns out to be an obtuse triangle, I will want to extend so that I can find out where they intersect. But right now, I'm just drawing in the altitudes. All right, let's look at the next one. We'll start at A, which means across from A is MR. So the slope of MR, I'm going to have to go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. Those are both divisible by 2, 2/3. So my perpendicular slope, if this is a positive 2/3, we're going to be negative, and then flip it over 3/2. So from here, I would go down 3/2, down 3/2, but that's going to take me away from where I want to go, so I'm going to do it backwards. Up 3, back 2. Up 3, back 2, till I hit the other side. Up 3, back 2, up 3, back 2. So look what happened. My altitude is the side of the triangle. Any ideas what that means? All right, you may know what that means. We'll talk about it here in just a minute. Okay. So, if I have a right angle there at the corner, what type of triangle is this? It's a right triangle. Okay? So, if it's a right triangle, I can already see that when I come over here to M, the slope across, since I just made this line using a slope of -3/2, I know the slope of RA is going to be that -3/2 without even having to count, because I used that slope and made that line. Okay, so the perpendicular slope is going to be positive 2/3, which is the one I used for here. So if I leave M and I go up 2/3, up 2/3, it makes this side, and it makes this right angle. So this is a right triangle, which we already noticed in the first video, that means the orthocenter is point R. It's that right angle. Which was -1, 6. Okay, so anytime you have a right angle, we know that's going to be, if that's at the corner, we know that is going to be our orthocenter. Okay? If you have any questions still on altitudes and orthocenters, please make sure you ask during sync time. And then also, if you have any questions on your assessment, you can ask during sync time. And there's also tutoring available. Okay? Thank you so much for watching.